Hello and welcome to the Vibration Research webinar series. Today we're going to be talking about the vibration research hardware equipment like I have here. Some of the things we'd like to go over are the different pieces of hardware, but to start we always like to talk about the different values that we have. We talk a lot about collaboration, capable and competent, accountable and responsible, strong and driven work ethic, doing the right thing, as well as innovation. That kind of drives everything that we do at Vibration Research, driving both the software team as well as the hardware team, coming out with different pieces of hardware like these to help in different other projects and applications that we see in the market. Some of the software innovation that we've done since we started in 1995 starts with field data replication, where you can replay some recording time events one-to-one back on a shaker system, and then that kind of follows all the way through to today where we've come out with STAG software. Many of the other advancements we've made over the years would also include Kurtosion, getting those peak Gs back into a random test, fatigue damage spectrum, where you can equate how much fatigue a product sees in the real world and equating that to a random shaker test, as well as instant degrees of freedom, or IDOF as we call it, so you can more accurately and quickly get the random test up to level and see those smooth control lines that we all like to see for a high acceleration, short duration test. The Vibration View software that we use for the 10500, 9500, and Observer 1000, we have sine, random, shock type testing modules. Those would be the main modules that we have. There are sine on random, random on random, all the mixed mode types of applications that you can have. Shock response spectrum, user-defined transient capture, as well as field data replication, and many more. So there's lots and lots of different control software that we use with the Vibration View software. And then we also have access to the ObserView software. In ObserView, users can view, edit, and analyze waveforms from recorded or live data. So this is a powerful and efficient vibration analysis software. It includes specialized modules for waveform recording and test generation. So that's what we'll look at in other webinars that we have also recorded on our website, where we have the use of Live Analyzer and taking data as we recorded it in the field, but then also analyzing it and looking at what the PSDs are, or looking at an FFT, or doing some other order analysis or octave analysis, as well as looking at live FDS and post-processing FDS of a waveform. The goal of the webinar today is to go over briefly the different pieces of hardware that we make at Vibration Research. This is not to be in-depth on the hardware that we design, but it is to go over the different hardware that we have so that you can see which one works in your different application. Alright, so let's get into the hardware. So this is the array of the different types of hardware that we make at Vibration Research. Vibration Research designs, manufactures vibration control and data acquisition systems for vibration testing on any electrodynamic or servohydraulic shakers. The 9500 that we have here is the best-selling control hardware for vibration and shock testing. It's scalable up to 128 channels and features sample rates that include up to 200 kilohertz and 2 outputs for this piece of hardware. The 10500 is our high channel count control hardware for vibration and shock testing. It's scalable to 512 channels and features a control sample rate of 256 kilohertz and 4 outputs for multi-shaker testing. We also have a little bit more a couple more outputs that we'll talk about when we get into the VR10500 in just a moment. The controllers themselves use a high-speed RISC processor that can process large data sets efficiently and run vibration tests at low and high sample rates. They are capable with all electrodynamic and servohydraulic shakers and it can function as a data acquisition device as well. It's just not as portable as the next piece of hardware, the Observer 1000. This is the next generation of technology that we have here at Vibration Research. It's used for field data collection and analysis of that. So that's where we use the ObserView software, which we have gotten into in other webinars, but for this one we're just talking about the hardware. It's designed for mobile use. It's compact. It's just 1.5 kilograms. It's battery powered, has an integrated SD card, which we'll run through all of these in just a moment, but it also has 16 channels in a handheld piece of hardware. We also manufacture and develop all of these at our facility here in Jenison, Michigan. So we do all of the design, development, and the manufacturing process is all done in the United States. All our software is developed at our Jenison, Michigan facility as well. We also offer a small line of low force shaker systems. This would be one of them. This is our smallest one. It is what we call the VR5200HF. We'll be running through some of the specifications on these here in a moment, but the 5200HF is typically used for some modal testing as well as for running accelerometer calibration in a back-to-back application, and we also have that application webinar on our website as well, so you can take a look at how that works as well. We offer from this size shaker system of 13 force-pounds up to a just over 600 force-pound shaker system. So we'll go through those here in a moment. The first piece of hardware I'd like to talk about is the Observer 1000. This is the Observer 1000, that handheld battery-powered data acquisition device. It features 16 channels. Channel 1 is a BNC. Channels 2 through 16 are a LEMO connection, so you could either plug into that directly a triaxial sensor, or you could plug into that our breakout cable that breaks this from a LEMO to 3 BNCs. We do this for a couple of reasons. One, for the XYZ type sensors, so you can plug them directly in there, but two, it's also so that you can keep that unit to be a handheld unit when you're in the field. It also features a microphone input on the front so that you can talk your notes into the application, so that when you're looking and viewing these files later, you can go back to look at your notes and listen to them live. On the back side of the Observer 1000, there's an SD card slot. That's where it's storing locally all of the data that you're capturing. It also features a connection for a GPS, so then you can plug that in and also look at that in the ObserView software to see exactly where the data was precisely taken from as well. It has an Ethernet connection on the back, so you can directly plug that in, so you don't have to connect to it via Wi-Fi. You can also connect to it directly to the PC with an Ethernet connection. The back also has an output, so you can use this for modal type testing. You can also use this for connecting to Vibration View, so you can actually use this device as a controller as well. So just like the 95 and the 10500 we'll talk about in a minute, this can also be used as a shaker controller. And then it also has power for charging the internal battery, as well as power for using external batteries, so you can hot swap those as well. The device itself emits an ad hoc network, so you can view what's happening live while you're taking data in the field. I'll demonstrate that now with what we call VR Mobile. It's our application you can get for free using your iOS or Android app stores, and you can use the NFC tag that's behind the VR label here. When I hit scan to connect, it goes and loads that. So now as it loads, now I can see what's happening live I don't have anything connected to it right now, but I can see waveform and the FFT of all of the channels that I have on this device. So waveform and FFT is a nice way to see what's happening. And then what I can also do on the app is hit the record button down here, so I can record remotely, starting and stopping recording on the device. And now I can see that happening both on my hardware as well as in the VR mobile application. The device also on the box itself has a couple of buttons at the top. Those buttons show and indicate what's happening live on the system. So this is recording. I can also stop the recording here, and it will stop my recording of the vibration test that I'm doing, and now it's paused, storing all of my data on the SD card in this case. One other feature set that is on the Observer 1000 is when I flick the power switch here. I'm just going to flick it real quick. You can see the battery status of the internal battery. For about 3 seconds it'll show up above the VR logo, and then you can see how much battery you have in the internal of the Observer 1000 as well. And also coming soon to the Observer 1000 is the ability to input a CAN signal, so you can see what's happening on your equipment live while you're getting the vibration data or whatever type of sensor you have hooked up to the front. You'll be able to hook up in the USB connection on the back of the Observer 1000 and be able to use the CAN data from your device that you're also running your tests on as well. The next piece of hardware I'd like to talk about is the VR9500. That's this box right here in the middle, and here are just a few key features of the VR9500 hardware that I'd like to talk about. It has a gigabit Ethernet interface providing that high bandwidth connection to the PC. By using Ethernet, the 9500 can be located up to 100 meters away from a PC. So with an integrated IEEE ICP supply, the 9500 can supply power. It's up to about a 4 milliamp signal to any accelerometer or transducer that complies with those common standards for the front inputs of the VR9500. The 9500 also understands the Transducer Electronic Data Sheet, or TEDS as it's called, and that's a standard way for sensors to store information about themselves, such as their sensitivities as well as when they were last calibrated. Supporting up to 26,000 lines of resolution, the 9500 can provide outstanding control for high frequency, which is really critical for products with narrow band resonances. Multi-unit systems are scalable then to 128 channels, and that comes in 4 channel blocks. They would be connected via an Ethernet switch. All of those would get connected together either with an Ethernet switch or daisy chained together. On the back of the box there are the expansion inner box option next to the Ethernet, and you can use those as well for the high channel count 9500 options when you get into sizes like 128 channels. Multiple 9500s can be rack mounted or stacked on a desk then as well. Its inputs also have 200 volt tolerant self-resetting fuses on the inputs to protect the controller from high voltage transients. So if you accidentally threw power at one of the inputs, the box itself would not be used as a fuse. There are fuses on each one of the inputs themselves. The 9500 does not require any special board in the controlling PC. All the critical calculations are performed in the 9500's RISC processor, and the results are communicated via that Ethernet connection to the PC. The PC then is used only for the user interface and data storage, so nearly any standard Windows PC is compatible with this controller. Back of the 9500, there is the drive output to drive a amplifier or any shaker system really. It also has a COLA output for hooking up to a stroboscope, or sometimes you can use this in a dual phase setup for multiple shakers. Next to that is the aux inputs and outputs. Those can be used for digital and analog type signals to communicate with external equipment. One of those things would be using that to connect to a chamber so that you can run while the vibration test is running. If the chamber stops for some reason during a shake and bake test, you can stop the shaker so that the product does not have more hot-cold testing being done to it while the vibration test is stopped, and vice versa. So that communication can be key while you're running shake and bake testing, as it's called. Next to that is that Ethernet interbox option that we spoke about already to connect high channel count systems. And then there is the network cable next to that. That's to connect to the PC itself. And then you have next to that is the fan, as well as a grounding screw next to that, and the power switch next to that. One of the key features of the VR9500 is also its ability to mix and match the hardware. So you could have multiple shakers running with 9500s at each station, and then take both of those or all of the systems from all the shakers and stack them on top of each other for an application where you can have 20 or 32 or some high channel count solution, even though you only have 4 channels at each shaker system. Combining them all together can also give you a way to scale up to a high channel count test, especially for the labs that have multiple 9500s and only once in a while run high channel count tests. One of the other applications you can use with our hardware is it is also rentable on a monthly basis. So if you have once in a while high channel count tests you need to do, you can also use that and borrow those from us, and we can send those to you. The VR10500 is the latest piece of hardware that we've come out with at Vibration Research. The 10500 is a high channel count option for advanced testing. So it's a 16 channel unit with multiple outputs on the back. It's scalable, also up to 512 channels. Like the 9500, the 10500 has an integrated IEPE power supply to provide power to those IEPE or ICP type accelerometers or transducers. It also understands TEDS, that transducer electronic data sheet, so we can read and rewrite the data on the TEDS chips. It supports up to 26,000 lines of resolution, also has 200 volt tolerant self-resetting fuses on the inputs, and it does not require any special board in the controlling PC. The 10500 also features 4 independent analog outputs for multi-shaker control that can be used for running a single axis shaker. You can also use that for running dual axis shakers. You can also use that for running a tri-axis shaker, so X, Y, and Z type shaker systems, as well as running 4 outputs for 4 post-testing scenarios. It also features a digital output interface that provides 2 additional drive outputs, so you can technically soon do up to 6 outputs on the back of the VR10500. The digital output is a digital signal that comes from the 10500, and on capable amplifiers can also then read that digital signal and convert it to an analog signal in the amplifier system. Some of the colors that are featured on the front of the 95 and 10500 are red, yellow, and green. Green is good when we're providing that IEPE signal to the front inputs. That means we are providing power to an accelerometer and it is getting good feedback, so it's a green LED status ring around the front of the unit. The other color is yellow. Yellow is a color that means it's getting close to the saturation point of the sensor that you have hooked up. And red means that it is either saturated 100% of the signal, or maybe it also has a signal that it is not able to get any feedback on anymore. So maybe the accelerometer cable is broken, or maybe the BNC has been taken off the front of the 105 or 9500 as well. The back of the VR10500 also features those outputs on the right hand side. It also features, just like the 9500, an aux inputs and outputs for that digital and analog communication with other pieces of equipment. And then next to the aux inputs and outputs is the interbox option for connection to the PC, and they also will daisy chain then together. that way. There's an expansion slot so that you can actually use that next to the inner box. There's an expansion slot so you can use that as an Ethernet connection. So they will also daisy chain in that fashion, as well as the normal network slot next to that that you would connect to your PC with. And then next to that again is the fan for cooling the unit, as well as the screw for grounding to the amplifier, as well as the power module. We also offer a line of small shakers for turnkey testing solutions. The lines start at a 13 force-pound shaker up to just over 600 force-pounds for that whole turnkey system when you need to have a controller, amplifier, shaker, accelerometer package all in one. We do offer that as a solution for that small amount from this 13 to a 600 force-pound. We can work with any electrodynamic or servo-hydraulic shaker manufacturer on the market, so whether you're buying a new system at any size or have an existing system that you'd like to update the control hardware on, we would be happy to help in that. Any of them can be run with our VR9500, our 10500, or our Observer 1000, and we can use those on any size or any make and model. Trying those out is a great way to see once if that would work for you, and we also offer these for demonstration purposes, and you can use them for weeks at a time and see once if it does work in your daily use. We have many sales and support offices around the world. While we are in the Grand Rapids, or in this case Jenison, Michigan location, that's where our headquarters is, we do offer sales and support offices around the world, and you can see on this map that we cover everything from West Michigan to West Virginia to Western Asia. So whether you have any application in there, we'd be happy to support. If you're not sure which hardware is capable for your application, we'd be happy to go through that with the different application engineers that we have here at Vibration Research and allow you to use one of these pieces of hardware for a few weeks at a time to try them out. Thanks for watching the webinar. Remember to download the software and also try out our hardware. You can use this for weeks. It's fully enabled, and we'd be happy to send one to you.